Practice set 4, problem number 1. A person wants to put a fence around this small plot of land. What length of barbed wire will you need to enclose this small plot of land? Assume the fence is made of 3 strands of this wire. In other words, they want to go around the plot 3 times. Sometimes drawings are made with very few dimensions shown. This is often done to avoid clutter on the drawing, but it does place some responsibility on the person looking at the drawing to fill in the blanks. Just because 2 sides do not have dimensions means that we can ignore them. So our first calculation before determining the perimeter will be to find these missing dimensions. If you look at the overall picture, this horizontal span of 900 would be the same as the combination of the 280 foot given and our unknown. So to find our unknown horizontal side, we're going to take the entire horizontal distance of 900 minus the dimension here given of 280, which results in a dimension of 620 feet. Using a similar approach to determine this vertical span that we don't know the dimension of, we will take the entire left-hand vertical span, which has a dimension of 550 feet, subtract the portion that we know on the right-hand side to give us this missing vertical dimension of 250 feet. We now have all the dimensions of this field and we're ready to find the perimeter. So we can start anywhere, but we can start over here and continue around clockwise on this field to give us the perimeter. So we have 550 feet plus 900 plus 300. The dimension we found, 620, plus the second dimension that we found, 250, and last, to bring us back to where we started, we'll add 280 onto that. The result is 2,900 feet. In word problems, it's always a good idea to make sure you answer the question, and in this problem, it's telling us that they're going to go around 3 times. For the fence material needed, we will have to take that perimeter then that we just found and times it by 3. Felt like we were done, but we hadn't answered the question by just finding the perimeter. Our final answer then to take care of finishing this problem will be to take the perimeter times 3 to give us 8,700 feet. B asks how many fence posts will be needed if they are to be spaced 8 feet apart. And what we have is the perimeter value of 2,900 feet. We'll take that and divide it by 8 because we're looking at how many 8-foot sections are there around this field, which will give us the number of posts needed. When you do the division, you end up with 362.5. Since they're posts, we need a whole number, and rounding this to the nearest whole number, the 5 in the tenths is enough that we will need 363 posts for this fencing of the field. In problem number 3, they ask us to determine the perimeter of this object. Well, this object appears to be a semicircle. If we could visualize this as a whole circle, we could use the circumference formula and then half it to give us that perimeter of the semicircle. Circumference of a circle is found by taking pi times the diameter. We'll use the approximate value of 3.14 for pi. We'll multiply it by the diameter given of 12.75, giving us a circumference of an entire circle with this size diameter of 40.035. However, we only want the semicircle, or half of this distance around, so we'll divide that value by 2, resulting in a measurement of 20.0175. In this problem, they're asking us for the perimeter of this object. What we've calculated right now is approximately a 20-foot distance, but it isn't the perimeter of the object. We started here. Going around to this point doesn't go all the way around, so our final calculation for this answer means we'll have to add on this lower piece here that we treated as the diameter of our semicircle. So we'll take the perimeter of the semicircle, 20.175, add the diameter cross piece to finally give us the distance around, or a perimeter value of 32.7675. The instructions tell us to round to the nearest hundredth. So if I go to the hundredths place and look at the thousands, 5 or greater in the thousands, we'll add 1 to our hundredths value. So our final answer is going to be a 32.77 feet.